Good evening everyone. My name is Leela Pawan Kumar Verma. I am from RVR NGSC College of Engineering. Today I am here to present my internship report on IoT from Emertxe. So these are the topics that were covered during my internship: C programming, C++ programming, introduction to embedded systems, ARDUINO programming, a project introduction, learning about the peripherals, implementing individual components into a connected application, and then simulating. So C programming. C programming is the basic programming language, one of the most popular programming languages. Dennis Ritchie invented the C programming in 1972. He inherited the features of existing programming languages. Those are B and BCPL. The below is the evolution of programming languages. First one is ALGOL 60, then CPL, then BCPL, then B, also known as basic language, and C. So these are the features of C programming. C is a middle level language. It consists of both assembly level language and high level language features. So it is a procedure oriented programming where everything is written in the form of functions in a procedural way. C has few words, which means it contains only few keywords, that is 32 in number. C is a portable language. We can carry the executable C file and it can run on any platform irrespective of the operating system. C is powerful and flexible. C supports all basic features and functioning. C is also known as the programmer's language, which means the one who is a beginner in programming must learn C to understand the basics of programming, the syntaxes, the semantics, etc. Here is the structure of C program. The first line contains the header files, followed by the main function, which is the heart to the program. Every execution starts on the main function. Here we declare a variable int a is equal to 10, which is the variable declaration should be at the beginning. The body contains a printf statement to print the variables. At last there should be a return statement. Return statement is not mandatory because we have given int main, we should return 0, or else we can give void main and no need of return statement. So we should also have an idea about number systems before going into the project. We discuss about 3 number systems: hexadecimal, octal, binary. Binary takes values as 0 and 1. The octal has 8 values, 0 to 7 range, and hexadecimal has 16 values, 0 to 9, and from capital A to capital A. The below are the conversions from decimal to binary, decimal to octal, decimal to hexadecimal, and binary to decimal. The conditional statements in C. C contains a conditional statement, that is if and else statements. We give a condition inside a if function. If it is true, then the statement associated with that function is executed. If it is false, then the statement associated with else block is executed. There can be nested if else statements, where if else can be declared inside an if else statement. There is no issue. The one line statement, popularly known as ternary operator in C, it returns a value. The value is based on whether the expression 1 is true or false. If the expression 1 is true, then expression 2 is evaluated and that value is returned. If expression 1 is false, then expression 3 is evaluated and that value is returned. There is another statement, conditional statement in C known as switch, where we give an input to the switch. This input is compared through all the cases defined inside the switch case. Whichever case is matched, the related statements in that case gets executed. It comes out of the case. Break statement is necessary. If none of the cases are matched, then the statements inside the default block is executed. Looping statements in C. C contains 3 loops: while, do, while, for loop. Supports only 3 loops. There are many looping statements like for each loop, but it is not supported by C language. See, while loop called as entry control loop. So there is a condition that we must satisfy before getting into the while statements. So at the entry stage it is checking the condition. So entry control loop. Do while syntax is similar, like do open braces close braces inside statements. At the end of the close braces we specify while with a semicolon. So in a do while, first we execute all the statements and then we come to the while where we check the condition. If it is true, then again all the statements are executed, else we get out of the loop. So at least once the statements are executed in do while, so it is known as exit control loop. For is a simple loop where we initialize the variable with a condition and an evaluation expression. This evaluation expression is necessary so that at any point of the time we either break or meet the conditional statement to get out of the for loop to avoid infinite loop. So below is the basic demonstration. I takes the values from 0. I should be less than 3. After implementing printf statement, I value gets executed by 1, increased by 1. So at values I 0, 1, 2, the printf statements will be printed at I is equal to 3, 3 less than 3, the statement is false, comes out of the for loop. Functions. There are inbuilt functions and user-defined functions in C. Inbuilt functions can be imported from the header files. The user-defined functions are defined as follows. There should be function declaration if the function is called before the definition. So the declaration is as follows: return type of the function, space, the name of the function within the parenthesis. The data type of the parameters that is passed to the function must be given separated by a comma and a semicolon is first. Function definition is easy. The return type of the function, space, the function name inside which we pass the parameters with the data type and variable name. We open the brackets, we write inside the function definition. Here int add takes n1 and n2 of integer type as a parameters. It returns integer type. So here the sum is calculated and returned. So pointers is a variable in C which stores the address of the any data type. So pointer is an integer, contains an address, can be used as referencing and dereferencing operator. Pointer is of arithmetic type, it can point to nothing. Then we call it as null pointer. There is a dangling pointer, wild pointer, etc. in C. It helps in dynamic allocation of memory. So while initializing an array, if you give int arr of 5, then for that array 5 blocks of memory is fixed. But we may or may not use the 5 blocks throughout the program. The memory gets wasted. Instead, we can use the dynamic allocation where at that given point of time how much memory is used by us will only be assigned to us. We make use of pointer to attain this. There can be integer pointer, char pointer, float pointer, double pointer. Here this is the pictorial representation of pointer, of how pointer is storing an address of a variable num. So pointer ptr refers to the num, it stores the 200 as its address. While dereferencing, we use star ampersand the pointer name to get the value present at the particular address. Macros and header files. As we discussed, header file are the essentials that a program must contain. Like stdio.h should be included to access the input-output functioning. String.h should be used to access the string functions. stdlib is used to access the memory allocation functions. So macros. To define a macro, we use the syntax hash define macro name followed by the value. We can also include user defined header files The syntax hash include within double quotations the name. So in embedded programming we use the set bit. We can also define the function as a macro. Simple functions as a macro or a simple operations in a macro. Macros are type insensitive, recommended for smaller operations. Those are time optimized. So these are some inbuilt macros. For example, underscore file underscore current file name. We can also access date, current time, function name from where you call the macro, and also the line number. Here the if and def means if the macro is not defined, then define. To avoid the name errors, we make use of it. Coming to C++, it was invented by Stroustrup in 1979 at Bell Laboratories. Initially they called C language with classes. However, in 1983, C++ name was coined. So C++ is a statically typed, compiled and general purpose case-sensitive programming language. It is both the combination of object-oriented and procedure-oriented programming language. It adds new features to C language. Hence, it is also considered as the superset of C. The object-oriented concepts in C++ is as follows: encapsulation, which means wrapping up of data and objects into a single unit. Abstraction means hiding the internal details. Polymorphism is the ability of an item or a variable or an object to show more than one form. A class is the basic building block of the object-oriented programming. Object is the instance of class. So we can create many instances of the classes, which is called as objects. The inheritance, we can also inherit the functions of another class to the present class using this inheritance, where superset, subset, superclass, subset comes into the matter. Structure in a class can be defined in C++ as follows. Structure is just a data type. Read is a user-defined data type which contains the integer values, string values of our choice. It can contain the pointer also. Whereas in class, if we define any variable, those are known as class variables. We can also define the methods inside the class, constructors of the class, where these class variables are accessed through the reference are known as object. In main, both the class variables and the struct variables are accessed as follows. Embedded system is a combination of hardware and software to do a particular task. This is the architecture of the embedded system. It contains the software as its upper level, and a lower level it contains the sensors and actuators, where sensors take input from the environment, process those analog inputs into the digital inputs, where it is given to UC. That UC process the functioning and it returns the digital value. We convert the digital value into the analog value and we give it to the actuator, where actuator takes electric signal to perform physical task. This UC also takes the help of memory. IoT. The IoT architecture is as follows. It contains 3 stages: device connectivity, data processing and presentation. The connectivity, here all the external devices comes into consideration. Example, existing IoT devices, the gateway, low power devices, IP capability devices, etc. is connected to the backend through cloud gateway. In our project we use BLYNK IoT. The backend we can code using many languages. Here in our project we make use of embedded programming with the help of C and C++. And the output, or as a presentation and business connectivity, is provided at the third layer. This is the basic ARDUINO UNO board, where all the simulations takes place, contains the analog pins and digital pins. we make use of ARDUINO mega microcontroller in the ARDUINO UNO board to implement our project. Contains USB port, power jack, different pins for different functions, reset button, etc. This is the IDE, ARDUINO IDE, through which the real world IoT applications can be programmed, and also the simulators can be programmed. This contains two blocks: setup, loop. Setup is for initialization only. Loop means the main code. Coming to our project, home automation. Here the scope of our project is using PICSIMLAB and BLYNK IoT mobile application. We should control the garden lights, temperature of our home, inflow and outflow of the water in the tank. We assume that all are simulated and no real objects are included. We depend on BLYNK IoT mobile app. The no restrictions. Coming to function requirements, garden lights control. Here ARDUINO UNO takes input from LDR sensor. Here LDR sensor is a sensor that regulates the brightness of the light depending upon the outside sunlight. The more is the sunlight, lesser is the light. Less is the sunlight, more brighter is the light. So we get the LDR sensor. We process them and the output is garden lights. Next one is temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. It resembles the temperature control system at our home. The ARDUINO UNO reads the temperature from the temperature system, and based on the inputs given by the BLYNK IoT app, based on the user toggling the pin value, the heater and the controller or cooler is controlled. We display the output on CLCD and also on the BLYNK IoT app, the notifications and all. We also display the temperature on BLYNK IoT app through widgets such as the temperature gauge. So requirements: temperature control system. To output temperature, we must read the temperature from LM35 sensor and display it on CLCD and also on the gauge widget. The heater control system. Input buttons. We create a widget of BLYNK IoT app through which we toggle the heater. The button is at logic high, then we turn on the heater. If the button is at logic low, we turn off the heater. Similarly, the cooler is also implemented as the same, with the different widget button for the cooler separately. And here is the function, threshold temperature control function, whereas it defines that if the temperature exceeds 35 degrees Celsius, then the heater must be automatically turned on, and notification should be sent to BLYNK IoT app stating that heater is turned on, and we also display on CLCD. The third requirement of our project is serial tank, where we read the volume in the water tank using serial communication and we display on CLCD, not only displaying the volume but also regulating the inlet valve and outlet valve depending on the volume of the water. So we make use of ARDUINO UNO board, CLCD to display the output, the water tank, serial water tank. Through water tank, volume of the water is sent as an input to ARDUINO UNO, and depending on the volume of the water, whether to turn on or turn off the inlet and outlet valve is decided. The BLYNK IoT app sends the inlet valve control and outlet valve control pin values to ARDUINO UNO. Depending on that values, our inlet valve and outlet valve are controlled. We also display the volume of the water on BLYNK IoT app using terminal window, and also the notifications. On CLCD, we display the volume of the water and notifications. These are the requirement tables. To display the volume of the water, we just read it from the serial tank using serial communication. and we display it on CLCD. To control inlet valve and outlet valve through the button widgets in BLYNK IoT app, depending on the pin values, we on or off the inlet valve or outlet valve. If the logic is high, we turn on. If the logic is at low, we turn off. To control the volume of the water in the tank, if the volume of the water is less than 2000 liters, the maximum volume of the tank is 3000. We set it to 3000. If it is less than 2000, then automatically the inlet valve is turned on, and when the tank is full, the inlet valve is turned off automatically. So this is our user interface BLYNK application, where you can see the temperature gauge, the 4 switches. One is for cooler, one is for heater, one is for inlet and outlet. We can create these widgets in the home automation. Before that, we must create the data streams in our cloud. Means we should define the function, what type of argument does it take, through which pin it must be associated, what are its range, etc. Once we define data streams, we can attach each data stream to the switches. So after simulating all the above peripherals, here is how the output gets displayed. This is the CLCD, where temperature and volume and the notifications are displayed. You can toggle the garden lights using LDR function, LDR sensor and LEDs. Here on adjusting this blue scale, the intensity of the LED gets altered. Here this fan is nothing but a cooler. When we toggle, the cooler value is displayed here. It is the internet card. To connect to the BLYNK IoT application, we make use of this Ethernet W5500. This is the BLYNK IoT interface. This green button here signifies that our device is online. This is a serial tank. This red is the inlet, and this red is the outlet. So when we turn on the inlet, from here the water fills the tank. When we turn on the outlet, from here the water empties the tank. So these are the values, and low float and high float values, whether the tank is full or empty. And here the volume of the tank is displayed, the temperature of the water is displayed, etc. So now we are going to simulate all this. So this is our main program, home automation, and these are the dependencies. Initially, first we control the garden lights, which means ldr.cpp and ldr.h, two files we have taken. In ldr.h, all the header files are defined, where the LDR sensor is connected to A1 input, garden light is connected to digital pin 3. In ldr.cpp, we initialize the garden light to output and the LDR sensor to input. We control the brightness through the below operations, where LDR sensor outputs the values from 0 to 255, whereas the Arduino Uno reads the values in the range 0 to 1024. So after performing analog read function, we get the value in the voltages. So we convert that 1024 bytes value into 255 range value, and we reverse it, so that the garden lights can be triggered. If the voltage is low, then it should be high, and if the voltage is high, then the garden intensity should be low. We placed here a delay of 100 milliseconds to vary the output. Here we must initialize the ldr.h. We include this ldr.h and nothing else. We directly go into the void setup and void loop. In void setup, just we initialize the LDR, and in void loop we implement the brightness control function. So our garden lights gets initiated. The next one is temperature system. Here we contain the header file which contains the all pins are set to input and output values. Your heater is set to pin 5, cooler is set to pin 4. The input is taken from pin AI0, that is defined as temperature. Read temperature value, read temperature function, the initializing the temperature, the cooler control and heater control are all defined here as a signature. Getting into the function, here we set the temperature sensor as an input, heater and cooler as outputs. We read the temperature using analog read function, where we get not directly the temperature value but the voltage value. So we multiply it with 4.9 millivolts and we divide it with 10 millivolts, so that we get the correct temperature value in degree centigrade. Then we return the temperature. Cooler control and the heater control are based on the control value. The control is set to 1, then we turn on the cooler. The control is set to 0, then we turn off the cooler. Similarly the heater control also. Coming to the main relation, so to connect to BLYNK IoT, we have individual BLYNK template IDs. The template name I have defined it as home automation, and this is my authorization token. Using this token I can access my IoT devices from anywhere on the world. So first we connect it to the Ethernet using SPI Ethernet.h and the BLYNK simple Ethernet. These are essential. And we make use of liquid crystal I2C CLCD. So we get it through liquid crystal I2C. Whenever we use I2C as a protocol, it is always associated with wire.h. So we include the main file, the temperature system.header file, and we store our authentication token as a character array. We initialize the pins as goal. We start the timer. We initialize the LCD with base address as 0x27 2x16 size. We have BLYNK write function, cooler pin, heater pin. Based on the input given by the BLYNK IoT, we set the cooler pin or heater pin to on or off, and we display it on the CLCD. So we update the temperature reading using BLYNK virtual write on the temperature gauge every now and then, so that the accurate temperature gets displayed on the temperature gauge. To handle temperature, there is a condition: if the temperature reaches 35 degrees and more, the heater pin should be turned off. We check here whether it is on or off. If it is on, then the heater pin should be turned off, signaling the BLYNK IoT app and also printing on the CLCD. Now here is the serial time, all the header files where all pins are set and all functions are initialized. Here we declare the functions here in serial time.cpp. First we fix the rate. In serial communication we fix the rate as 19,200 bits per second. At that rate the communication is carried out. To obtain the volume, we read it from the serial time, where the serial time outputs the volume in 2 bits, MSB and LSB. So here we left shift the MSB by 8 bytes and then we perform OR operation with LSB to obtain the correct volume. Here the serial.available function waits until the value is returned to ARDUINO UNO by the serial time. Enable inlet, disable inlet, these all are the basic functions to enable and disable the valves. Going to the main function, we include the serial time.h. here. Store the tank volume in this variable when we start the blink timer. It is necessary to start the blink timer. And it is the outlet and inlet pin we set here based on the parameters given by the BLYNK IoT mobile app to turn in or turn off, simultaneously updating on CLCD, and also to handle tank function. If the volume is less than 2000 and the inlet valve is off, we immediately turn on the inlet valve and we update on the BLYNK cloud as well as the CLCD simultaneously. If the volume is full or reaches 3000, both are same, the maximum capacity of the tank is 3000, then we turn off the inlet valve and we update simultaneously on the BLYNK IoT mobile app through virtual write function. Also we print it on CLCD. So these are the initialization, and here we call the function. Before calling, we initialize in the void setup. So now we compile the code. We export compiled binary file. No errors. So now we load the text file. Here is our file. We now loaded it. Okay. We now connect the serial tank. So the file gets loaded. We reset it. We can reset it. Yes, it is connected. And now here is our mobile application. Now we'll project my mobile to show how it is functioning. So this is my screen, and here this is my BLYNK IoT mobile application. It is online. So the serial tank is present here. So automatically when we toggle the cooler, here the fan is running. When we stop, when we toggle the heater, the temperature is rising here. So we can check here on the base also, on the CLCD also. And when we turn on the inlet, see here the inlet is almost full. Already the tank is full, so got disconnected. When we turn on the outlet, the tank is empty. Here we can check the volume gradually decreasing. So when it reaches 2000, it stopped. Why? Because if the volume is less than 2000, then automatically the inlet switch is turned on. See here, the inlet switch is turned on. Here it is visible here. So when we turn off the outlet, it gets increasing. When we try to off the inlet switch, it is off because it reached the volume more than 2000. Now we turn on the outlet, it is less. Yes, it is less than 2000. So we turn on the inlet. We again try to turn off. So here is the demonstration of my IoT project, BLYNK IoT mobile application. Thank you.